Welcome everyone to this month's edition of the AIG-ALS Queensland Branch Technical Series. This month we head off to New Zealand, where Craig Feebrey will give us no doubt an excellent talk on the geology of Waihi. I'd now like to introduce Craig Feebrey from OceanaGold Corp, who's going to speak on the geology of Waihi low sulphidation epithermal gold mine, New Zealand. Craig is a geologist with over 25 years of global exploration and commercial experience. He held senior technical and management positions across major international mining organisations and junior exploration companies. More recently, and in his current role, Craig has been executive with OceanaGold Corp and head of exploration for 5 years. Prior to this, he was Vice President of Exploration Australasia with Goldfields and EVP of Exploration with the Lundin Group of Companies. Craig spent over 13 years in Japan exploring and working on volcanic systems and epithermal deposits in Hokkaido and Kyushu, so he's well versed in low sulphidation epithermal systems. He holds a PhD in geology and a Master of Science degree from Hokkaido University in Japan and a Bachelor of Science from the University of New England, Australia. Thanks, Craig, and welcome aboard.
Okay, thanks, Peter. Can you hear me?
We can hear you.
Good. Good start. Good afternoon, evening and morning, depending where you are, for this talk today on Waihi low sulphidation epithermal deposits. The talk focuses on the geology in general, but I'll touch on the production history as an introduction and to frame the various veins that have contributed to a very long history of gold mining in the area, as well as a few examples of the discoveries. I think these are always interesting to understand. And I'll finish up with our most recent discovery at WKP. Excuse me, before I get going, I just want to recognize all the geologists over the years that have contributed to the knowledge of the area. And maybe some of you are listening here today. Okay, we're on the right slide. So the Waihi mine is located within the Hauraki district in the Waikato region in the North Island of New Zealand. The operations are somewhat uniquely located within the gold mining town of Waihi, which some of you may be familiar with. Waihi is a small town, shown there on the right-hand figure, situated about 142 kilometres southeast of Auckland City, shaded in the grey area there on the left-hand figure. So begin with the tectonic setting and some regional geology, just a very cursory look at this. I think the important thing to note is that subduction of the Pacific plate under the Australian plate was possibly facing southwest around 25 million years ago, at which time a significant change in tectonism started to take place, rolling back to be eventually northwest facing, convergent margin similar to its present form. The associated subduction of the Pacific plate initiated a series of volcanic arcs in the northern North Island, beginning with the Northland volcanic arc. In the Coromandel volcanic zone, we see predominantly andesites, dacites, and importantly, the bimodal basalt rhyolite suite associated with the back arc rifting from around 12 million years. And these rocks are underlain by the Greywacke basement, shown on the right-hand side there. Volcanism continued in the Coromandel volcanic zone until the late Pliocene, around 1.9 to 1.5 million years, when activity shifted to the Taupo volcanic zone, where it is represented by voluminous eruptions of rhyolite, plus lesser andesites and dacites. On the right-hand figure there, just a simplified figure of gold production in the Coromandel belt. See Waihi there. I'll go into the production figures later, but it's approaching 10 million ounces of production and endowment. Then there's a few other significant deposits in the Coromandel. Golden Cross is probably one that people are more familiar with, or Thames further up to the northwest, and then Correnso shown there also across on the western side. So there's a number of pretty important and, I guess, low sulphidation epithermal of quite exceptional grade in some cases. So let's step back in time to the late 1800s, in particular when gold mining had taken hold in the Hauraki district. This is a more or less when the photo was taken in the late 1800s. It's a view of the mining activity across Martha Hill, where the current open pit is located. You'll notice the old pump house, I think, on the left there, that kind of taller two-story building. And for those of you that had visited Waihi, this is the same pump house that is preserved on the open pit edge today as a tourist attraction. The area was mined from 1883 right through to 1952, so a significant length of time. And with a mine grade of approximately 14 grams per tonne gold, it was quite lucrative, 100 grams per tonne silver, more or less, for almost 5 million ounces of gold production. So a significant producer in anyone's terms. Moving ahead to around 1942, this is a black and white air photo over the township of Waihi. These are the level plans of the old workings projected to surface in yellow there. They mined over 15 levels and went down about 600 meters from the top of the Martha Hill. And as you can see, the veins extend for quite some distance, about 1.6 kilometers along strike. And as I said, they mined about 5 million ounces from the Martha Underground between 1883 and 1952, when the mine closed. Moving ahead again, about 28 years since the underground mines had ceased operation. Here in 1980, this was the air photo, coloured air photo. Exploration drilling between 1979 and 1984 by Waihi Mining and Development Limited and Amex Exploration identified large open pit reserves. And these reserves were based on the historically mined parallel veins of Martha and Welcome, shown there in the red where all the drill collars and traces are shown. And it defined an extensive network of braided mineralized linking structures, which together defined an open pit resource of around 10 million tonnes at 2.9 grams per tonne gold for just under 1 million ounces. So still quite significant, and was left behind by the old timers. I'll show you what these veins look like in a cross section a little bit longer, and you'll appreciate the splays in between the main veins. Consents to mine the open pit resource were granted in 1987, and mining commenced again in 1988 from an open pit. So we had a hiatus in mining between 1952 and 1988, some 36 years. So if we move now to, I guess, the second major production period of Waihi's mine life, 1988 to present. The air photo shown here was taken in 2011 or thereabouts and shows the Martha open pit replacing the Martha Hill. The pit here measures approximately 1 kilometre in the long dimension and is about 200 metres deep from the pit rim. The open pit mine actually stopped in 2015 during the sale negotiations between Newmont and OceanaGold following a pit wall failure on the northern side. There was about 80,000 ounces of reserve that was remaining left to be mined in the bottom of the pit at that time. Total production from the pit was just over 2 million ounces of gold, so it was significant. Nearly 14 million ounces of silver, with an average reserve grade of around 3 or just over 3 grams per tonne gold and 30 grams per tonne silver. Over the course of 2001 through to 2009, there were several underground mines discovered, or veins discovered and mines developed, together over 1 million ounces of gold. And these were established to complement the Martha open pit production. From 2015, when the pit wall failure occurred, production has solely been from the Correnso mine there. That's the underground development shown in green. Looks like some of the labelling has fallen off, but the the areas in the center there of Favona, Correnso mine, and associated veins, Union Hill principally, the southern area there of workings, and then the drives that continue out to the right as labeled as Favona, with not quite 500,000 ounces of production there. Oh, there we go, they're popping up. So the underground mine development was significant, about 1 million ounces or a bit over 1 million ounces, and importantly, helped with the economics of the Waihi mine, with complemented by the open pit. Just work out which slides I'm on. And it's probably just worthwhile pointing out on the air photo here, the conveyor belt. The conveyor belt extends from the edge of the open pit. You see that straight line tracking across to Favona, or across to the right or the east to the processing plant. It's about 1.5 kilometers. All the ore from the open pit was crushed on the edge of the open pit, and both waste and ore was a bit unusual, I guess, for Australian miners, was conveyed across to the plant and then separated. It was batched basically for ore and waste. So this brings us to today. The mine's currently not producing gold, although ore is being mined from Correnso still, but at a small scale, and is being stockpiled. Approximately 225,000 meters, I think, has been drilled since the acquisition by OceanaGold in late 2015, and several million ounces of combined resource, including some reserve, has been defined based on Martha underground, shown here on the right figure, on resources in gold, and the exploration target that we're drilling currently in purple. Resources in the Martha Phase 5 pit, that darker brown surrounding Martha pit, is a pit layback. Gladstone, small open pit near the processing plant that I just showed you, about 100,000 ounces. And then WKP to the north, which is shown on the left-hand figure there, those red lines indicating the veins, about 10 kilometers to the north, I think I said, is another significant new discovery and represents an important part of future development going forward. Just a quick summary of what I've talked about in terms of the reserves and resources over time. The important thing here to note is over 3 million ounces of production since the mine got going again in 1988. And there was a good resource base established. And then you can see incremental growth with, if we just follow that bright blue line on the bottom there, that's the amount of drilling that's been done over the course of time. Not a lot of drilling up to 2000, but then you see a bit of an increase under the Normandy days. Normandy managed exploration with the discovery of Favona. That drilling tracked pretty steady up until OceanaGold bought the mine, and then we ramped up exploration considerably. As I said, over 200,000 meters drilled over the last 4 to 5 years. And you can see also in grey there the significant contribution that drilling has made with respect to the addition of new resources. The most resources that have been added at a quick rate over the course of the mine life since 1988. So starting with some of the geology, and we have a plan view at the top and a cross section at the bottom there. Pretty simple representation of the geology in the veins, but I think it gets the message across. Host rocks comprise late Miocene, shallow, east-southeast dipping flow dominant andesite sequence. Their age is around 7.9 to 6.8 million years, and that sits within the Coromandel group, part of the Waipupu formation. Two dominant units are present, and this is important in the discussion going forward. A lower massive flow-banded quartz andesite, and an upper sequence of feldspathic andesite flows with local tufaceous horizons. Now, the contact area locally contains fragmentals between the lower quartz andesite and the feldspathic andesite above, and forms a local control to vein position, I guess, in a vertical sense, capping some of the ore shoots. Above the andesite sequence, over on the right there is the Favona tuff you see in the section, thin felsic fragmental unit that interfingers with the Favona hydrothermal breccia, and then overlying this is the post-mineralization dacite with an age of about 5.8 million years to the southeast. And argon-argon dating has the mineralization at Martha sitting around 6 million years. With more recent drilling, we now know that sinters sit on top of the hydrothermal breccia immediately above the Favona vein, and there's quite a bit of water table silica as well. In terms of the veining and host to mineralization at Waihi, the Martha vein system is the largest, the most well documented of the vein networks at Waihi. I said mineralization of these veins is around 6 million years, and the veins are numerous and form a large network that extends, as I said earlier, about 1,600 meters along strike. In depth, about 600 meters, at least of the known vein system. And when I say the Martha system, I'm really referring to Martha, Empire, Royal, and Edward, shown there as the main fissure veins, and hanging wall splays, really. The vein network, although complex in detail, simply comprises the dominant southeast dipping Martha vein, if you look at the section there over on the left, bottom left, and several northwest dipping hanging wall splays that include Empire, Welcome, Royal, and the Rex veins. The Martha vein is the largest vein, reaching up to 30 meters in thickness, but I guess that's 30 meters in thickness in certain places, but on average, it's around 6 to 15 meters. Increased vein widths are closely associated with steepening of the vein dips from an average of around 65 to 70 degrees to approximately 85 degrees to the southeast. Steeper portions of the vein also tend to contain higher concentrations of gold and silver. The vein itself, or the veins themselves, in particular Martha, comprise mainly brecciated quartz vein material, evidence for vein emplacement during the late stages of faulting. The quartz is characterized by multi-phase brecciation and banding, both coliform and crustiform, and quartz textures are highly variable from fine microcrystalline and chalcedonic character to more coarsely crystalline quartz, particularly at depth in some of the veins. Apart from the Martha vein, the hanging wall splays, they're also significant, well mineralized, and can reach up to around 18 meters width, so significant. The Empire vein is a good example of that. The hanging wall splays closest to the Martha vein have been shown to link up with the Martha vein at depth, often forming a high-grade lode at their intersection. Hanging wall splays further from Martha either thin out at depth or are not drilled sufficiently deep enough to make out the relationship with the Martha vein at depth. And not shown here, but Rex and the Ulster veins are good examples of that. Additional smaller scale splays are present linking the larger vein structures, and they form a valuable contribution to the mineralization, particularly in the open pit. These splays typically comprise smaller veins between 5 and 50 centimeters in width, infilling extensional structures with no fault displacement, dipping moderately towards the northwest. I'll also touch on the character of the veins a bit more later with a bunch of photos. And just to cap the overview, I guess, of the geology, a little bit on the alteration. The andesite host rocks within proximity to the veins usually have undergone fairly pervasive hydrothermal alteration, sometimes with complete replacement of the primary mineralogy. Characteristic alteration, assemblages of the host rocks are dominated by argillic alteration, silica, argillaria, elite and pyrite, closest to the veins, and then propylitic alteration, mainly weak silica, weak pyrite, carbonate, chlorite, interlayered elite smectite and chlorite smectite clays extend over probably tens of meters still laterally from the major veins. And probably the only other point from a general note is there appears that the system has undergone some post-mineral tilting, perhaps up to 15 degrees to the southeast. So from Martha shown there, tilting down to the southeast at Favona. It's getting a bit dry. So moving to a number of cross sections, we'll get into a bit more detail now, looking at the northeast through the Martha Hill vein system. So in plan view in the bottom left there, and then the sections shown, 3 sections by the blue lines on the top figures. The red lines are the projection of the level plans of the old underground workings projected to the surface. Gives you a good idea of the vein distribution, the major fissure veins. There are a few interesting features to observe from the figures. In plan view, the veins define conjugate northeast trends as well as north-northeast trends. Post-mineral tuffs cover the upper eastern parts of the system that you can see in the sections there. Probably a particular note is the prominent upward horsetaling of the Martha vein, the vein system, with development of extensional hanging wall splays. You can see that quite clearly in the section on the left there. The vein, or the Martha vein itself, defining what is interpreted to be a bounding structure to a graben or possibly a half graben, within which the upper felspathic andesite is preserved, as shown on the 2 sections on the right. Also note the upper termination of some of the hanging wall veins at the contact between the top of the quartz andesite with the overlying felspathic andesite. So the veins do tend to, and I'll give various examples and exceptions to this, tip out at the contact there. Just a few pictures of the open pit, or the pit walls and the structures. On the right there, we see the hanging wall splays of the Martha lode, shown by the arrows, the main lode, the thicker vein, and then some of the splays off that. And then on the left, we have the Martha lode in the foreground, and then the welcome vein in the background with a whole bunch of associated veinlets and splays. This is a figure that I think is quite informative. It's obviously the veins that sat within the open pit, the distribution of the main veins and the linking splays. It's much more evident here using the historic grade control data. You have the grade on the legend there on the right and the scale on the left. And it's a real credit, I think, to the mine geologists at the time. This was all done with channel samples and a jackhammer rather than drilling. But you can see the 2 prominent Martha and welcome veins, and then all of the step across splays and linking splays shown there. Same figure again. This is just the interpretation of the veins. You can see divided into the quartz veins, clay veins, or quartz clay, and then some of the stope fill from what the old miners took out. So now I'll just step through some of the photos of the vein character and then get on to some of the discoveries. Here we've got the photo on the left, number 1, coliform, crustiform veins, and these are common to much of the vein system at Martha at all levels in the system. The high grade photos in photo 2 and 3 there, you can see they're going well over 200 grams per tonne. These are typical gingro textured coliform, crustiform veins, quartz sulfides and quite a lot of sulfur salts in those veins. The number 4 photo is typical breccias that we see. They have low temperature silica, cemented sediment fill for those breccias, and then quite a number, not a lot of, but they're scattered through the deposits, a local sediment fill of voids as lenses within the veins, shown there on 5 on the far right, very finely laminated sediment fill. If we go lower in the system, and this is probably one of the things I just wanted to highlight as a part of this talk, was we're down here with these photos, and in a drill intercept there of W038, it's getting down towards the 500 meter RL, so quite deep in the system, 600 plus meters down the drill hole. We're starting to see a lot higher sulfide and base metal content compared to the shallow levels. Still see crustiform banded and brecciated veins. You see a bit of that in the photos there. There's also an increase in crystallinity of the quartz at depth in association with sphalerite, which is often dendritic, accompanied by galena and pyrite. There is a little bit of chalcopyrite in places, but it's really only very local and a minor component in the hundreds of ppm levels, I would say. The green there, or the pale green, is the alteration, and that's correnzite, the chlorite smectite, and that generally occurs here in bands. Other examples, if we move across to the main Correnso vein, here banding occurs again in parts of the vein, but it's not as widespread or dominant as you see in the Martha system or at Favona, where it's quite spectacular. These samples here are from Correnso West, which is in the northern part of the ore zone. And they're characterized, in addition to the quartz crustiform coliform veins, by sulfide rich and high-grade gold that you can see in those middle photos there. And here we see the very green alteration typical of correnzite in those photos on the right there. And as you may have guessed, the Correnso vein and the mines are named after the alteration mineral correnzite. Again, if we go lower in the system, we see the change in the vein character, or at least the mineralization. Not only Correnso, but other veins in the Union Hill area, Union, Trio, and Amaranth are other examples. And they're all characterized by elevated sulfide, including the base metals, lead and zinc. Still with adularia, dominant alteration, and correnzite, as you can see here. The far right photo is an underground sample, maybe a little bit hard to make out there, but it's a sulfide-rich band. I'll now go on to talk about the importance of the host rock and give a few examples of that, and the influence of the upper and lower andesites on vein and ore chute distribution. What we have here on the left is a long section of the Correnso West vein looking east. So you can see the Empire vein shooting into the section there on the left in purple and labeled. The Union vein over on the right, less significant vein, but still important. It actually goes into the upper andesite, and I'll talk about that a little bit later. But you see the Correnso West vein here really tracks on the upper or just below the contact of the andesite above and the quartz andesite below. And this is contoured in gram meters. You can see the high grade there, and the scale stretching at least 300 meters along the strike of the vein. and some late quartz calcite veins cross-cutting that do get up into the andesite above as well. Another example from the trio veins. This is a section across Union and Amaranth veins, and we can clearly see the impact of the host lithology on vein formation and mineralization. Quartz andesite is again a preferred host for mineralization. And importantly, the relationship is not exclusive. We do see good vein development and mineralization in the upper feldspathic andesites, but it's far better developed and in terms of ounces contained within the lower quartz andesite. You can see the widths and the grades there, so that's meters by gold in grams per ton. Much better width into the veins and much better grades within the quartz andesite. At Favona, I said there were exceptions, and Favona is one of them. It's a good example. Here the veins are sectioned through Favona. The mineralization is hosted entirely within the feldspathic andesite, and the Favona vein accounts for approximately 500,000 ounces. So it's still significant mineralization. It's well developed, so it's not exclusive. And as I don't mention it later, I'll just point out that these eruption breccias that we see at Favona, just shown there in the hatched and labeled Favona breccias, and the lapilli tuffs that form the apron there, and then you have the overlying post-mineral andesite conglomerates and the Black Hills dacite. And these were important in the discovery of Favona. It indicated that you're high up in the system and that the veins could possibly sit below. They're phreatic breccias, and with drilling they obviously found what was to be mined, 500,000 ounces of gold at Favona. Move on to the next slide. And this is another exception to the example, and I'm showing you this just as my learnings over time in these systems, not to be too dogmatic. It seems here at WKP the preferred host is the rhyolite flow. We have rhyolite pyroclastics above and below. Again, there's a few holes in the central area you can see there, and this is all gram meter coloured pierce points on the main East Graben vein. Pretty spectacular vein, this one. It has over 1 million ounces of contained resource now, with some very big intercepts. Discovery hole shown there at 8.7 meters at 25 grams. But the thing I wanted to point out here was just, again, the mineralization seems to be preferentially developed within this very competent rhyolite flow. Note the holes at the bottom there that were drilled before we got into here. There's 3 there colored up in blue, still mineralized, sometimes like the one on the left, good vein width developed, but not much gold in the intercept. You can see on the right there, hole 42, the true width and what the character of that vein is like. Maybe I'll just quickly mention the reason I'm talking about this, and given Peter mentioned my history in Japan, exploring around Hishikari and the systems in Kyushu there, prior to the discovery of Hishikari, there was very dogmatic. People were focused on the oxatsu andesites, which hosted some mineralization throughout the belt, and they didn't, once they were drilled into the Cretaceous basement rocks, they stopped drilling. And for those of you familiar with Hishikari, it's actually the basement Cretaceous turbidites or greywackies that are the preferred host for the mineralization at Hishikari. So lots of good examples there, and I guess the lesson is not to be too dogmatic about what's the preferred host. On to a few of the discoveries. Just check the time here. Oh, it's getting on, so I'll have to speed this up a little bit. We have the main veins of the Martha system in the center of the figure, and off to the right we have the Union and Amaranth veins. Early production out of Amaranth was around 2,000 ounces, while at Union it was a bit more substantial with 10,000 ounces. Trio presented itself at surface as a number of very small, narrow, centimetre wide veins, nothing significant. Early drilling between 72 and 2001 was pretty discouraging, with just low-grade intercepts. A small shaft, however, was sunk on the Union veins historically, and it was noted that they recorded high-grade veins striking in a different orientation to Union and Amaranth. Drilling was then oriented to drill across the apparent northeast strike, so moved the rig around, intersecting veins of good width and grade that became the discovery. You'll see there the 4 meters at 16 grams, for example. If we look at this in section, I showed this one earlier, clearly see the impact of the host lithology. The quartz andesite, again, preferred host for mineralization. The old timers were working these veins, as I just said, sinking shafts, getting deeper, but they were pinching out at depth, and they actually stopped and abandoned the mines before they got into the quartz andesite, where the veins improved again. And that may have been because some of the contact tuffs that mantle the quartz andesites, maybe that had something to do with fluid flow and structural development for these veins once it got into the andesite above. The Correnso discovery, it's an interesting story. Exploration was chasing the reptile vein there, just highlighted in blue. They thought it was another parallel structure to the Martha system. The team at the time were routinely orientating core, and then noticed that the vein that was being intersected in drilling was on a significant or a different orientation to what they were targeting. This all sounds familiar, I'm sure. Excuse me. So if we start looking at the discovery history here, I got the slide up. Yep. So there's a drill hole made by Kerr in 1986. In the absence of ORI data at that time, it was interpreted as the Royal vein, as we were just discussing. The grades weren't flash. They drilled a few veins, so they weren't motivated to continue exploring here any further. And remember, this is 1986, so one drill hole or a few without very good results. Fast forward to 2005, and Newmont were chasing extensions of what I showed as reptile vein, and they got this drill intercept shown here, 9.5 at 2.2, which I guess I'd call encouraging. And it had, excuse me, quite a bit of base metal. So the idea was to drill up dip. The ORI data indicated it was striking differently to what was expected, and the geologists again took note, and as I understand it, pushed to drill further. However, Newmont was not motivated to follow up, and it was under the Waihi, or as it was under the Waihi township. Took a number of years to convince senior management to get support to drill this, and it wasn't until the fourth quarter, I think, of 2008 that they could start drilling and follow up on the ideas. And so in 2008, quite a long time after the Kerr drill hole, the geologists under Newmont secured some funds and started drilling with the earlier intercepts, getting everyone's attention with the one shown here at 11.5 meters at 17.3 grams per ton gold. And that was really the discovery holes shown there for Correnso. It's a long section here. Again, the Empire, Martha, etc. veins are going into the section, and we have Union further to the east, sitting there on the right. That's the core. Won't really say much about that, just to say it's a great looking vein with great mineralization and gold grades there. And just to show you how it panned out over a bit of time, this is the Correnso long section of the west, and you can see the high grade hits there, a bit higher than the original discovery hole. above some of the base metals and great intercepts. And similarly, across on the eastern section, we have the ore body developing. And as I said earlier, about 500,000 ounces mined at around 7.6 grams per tonne gold on average, starting in 2014. I better conclude, I think, or wind up here. I just wanted to finish up with a few words around the more recent discovery. This one's at WKP. It's about 10 kilometres, shown on the left-hand figure there, about 10 kilometres north of Waihi. Gold was first discovered in 1888. Remember, this is the gold rush days around Waihi and the earlier photo I showed you. And a fellow called Kersey Cooper acquired the claim, and just based on a few assays, he raced off to London to raise some capital and develop it, claiming it was a deposit to rival the nearby Martha mine at Waihi. He went to all this trouble, built a 8-mile long tramway to the coast, mine manager's house, storehouse, assay labs, and on it goes. And it was only really when they began to prospect properly the claim by adits and shafts and intersecting what they claimed to be encouraging prospects, they started to realize that it may not have been as exciting as they thought. The mine manager arrived on site, stopped all the building of things on surface, and they eventually stopped exploring there, stopped developing, and abandoned the area when they couldn't find what they were really looking for. Lucky for us, I guess. Fast forward to more recent years, we've got a plan view of the WKP prospect on the left and some intersections on the right. These are the earlier interpretation, really from the Newmont days. You can see on the left there's 3 dominant veins. Scale there is about 500 meters long, so the far right vein shown there, the EG or East Graben vein, is well over a kilometre in strike length. 3 significant veins identified and some drill holes into them. You see, in terms of the geology, the rhyolite flows in the darker beige overlying rhyolite pyroclastics, and then younger andesites overlying that. On the right there, you see a section through those veins, the EG vein on the right, T-stream in the center, and the western vein on the west. And you can see there's some pretty good veins intercepted there. In the early days, it was really targeted as an open pit prospect, but these days we're just looking at underground opportunity. Interestingly, and as fortune has it, and this is the vagaries of exploration and companies and changes, Newmont did realize, and they had a hole into the East Graben vein, that's 7.9 meters at 5 grams or thereabouts, but for various reasons didn't follow up, and then sold the mine along with this prospect to OceanaGold. Fast forward to today, all those black traces of the drilling we've been doing in the last few years. You can see we're focused on the EG vein because we've intercepted spectacular widths, ore grade widths and grades with almost every hole that we've drilled since we started drilling the EG vein. And just a look at the long section there along the EG vein, south to the left, north to the right, in gram meters. It's the figure I showed earlier to highlight that here, different again to the Waihi and Martha systems, we have the mineralisation hosted by the rhyolite, and to a lesser extent, lower grade and less well-developed veins in the rhyolite pyroclastics. So very exciting for us at OceanaGold. This system is just beginning to be understood. We're focused on one vein with well over 1 million ounces in resource at around 12 to 13 grams average. And we're busily drilling this and hope to get on to the other 2 veins T-stream and western veins to see just how big this will grow. And like Martha and Correnso and Favona, as I've shown before, and for those of you familiar with these systems, I think it's going to be exciting times ahead. So with that, I think I'll wind up today's talk. I hope you got some insight into some of the geology and some of the learnings that we've been able to make from the benefit of the geologists over the years and the current team that are on site there at Waihi, led by Lawrence Torkler, the exploration manager there. So I'll hand it back to you, Peter, and see if we have any questions.
Thanks, Craig, for that excellent talk. We do have a couple questions coming in. I'll jump in first and give people a bit more of a chance to get some questions down. I guess now that you've got that slide on WKP up, and you showed I guess a regional picture as well with some of the other deposits and showings, there looks like there's I guess a concentration of deposits and showings between Karuhangi through Golden Cross and WKP, almost reasonably well lining up, and possibly parallel to the East Graben. Is that a real feature, or is it just a bit of I guess artistic license from the diagram?
No, I think, well, the guys on site who know a lot more about this than myself, to be honest, you know, over time we've had various consultants, various academics look at the regional setting. UMont did a big study of this area when they were there. And I think the general understanding is there is that northeast, southwest trend. It can be tied back to the regional tectonics, and as the convergent margin swung round to more of a northwesterly trajectory or subduction zone, there was subsequent faulting associated with that, and that tended to be on a northeast-northwest trend. So there is a dominance, I think, of that orientation, both of the veins and alignment of alteration zones and mineralisation. Probably the other one is association with, and we had extensional rifting taking place in this area, and that's in that figure at the very beginning. You saw all of those rhyolites were a function of the bimodal volcanism and filling of down thrown blocks. So I think the caldera formation, you know, dominant structural trends, subduction, all of that plays into that point that you mentioned.
Excellent. But Waihi seems to be alone in that. There's nothing sort of along strike to the northeast or southwest.
Sorry, I'm just thinking it through. To which direction?
I guess if you make a line parallel from WKP through Karuhangi, there's being sort of north and south of Waihi along that trend.
Yeah. Yeah, good point. Maybe we haven't found. I mean, we have some prospects up to the northeast. So we know there's big alteration systems there. We've drilled a lot of alteration, very strong, pervasive alteration in drill holes up to the north and northwest there that would be on that trend that you're talking about. Yeah, can't comment really. It's a good observation. Hopefully more to discover, I guess, is the answer.
Something to look forward to for next year's talks. Question from Mark Berry. In the last 3 to 5 years, there's been a large increase in resources, but this has not translated as yet to an increase in reserves. Is this lag due to technical issues with respect to conversion of resources to reserves, or some other reason?
No, it's just Mark, I think it was, Mark Berry. Mark, it's really, it's not a lag. We're flat out drilling. We've had a big program of drilling again this year, but there has been a focus on conversion, and there's a lot of studies going on this year as well. We've got the feasibility study underway at Martha Underground, and that will obviously convert a lot of the indicated material into reserves once those studies are completed. So we'll come out. Our normal reporting of the R&R statement is around the end of March. So we'll come out with an updated statement then that will reflect studies that we've been doing. And we start production in late first quarter or early 2021 with the Martha Underground, and we'll obviously have reserves in place by then.
Yep. Question from John Menzies. Have you found SWIRT and others to be useful exploration tools?
Have we found SWIRT, did you say?
Yes, to be a useful exploration tool.
Yeah, it's useful. In certain areas, there appears to be windows of exposure of the host lithologies throughout here, and we've used various tools depending on whether it's in covered material, so whether you have onlapping post-mineral volcanics or whether you have exposure. So we've been using all the different tools, whether it's remote through SWIR and LiDAR and gravity's ground, but remote gravity, aeromag, etc., through to more direct detection, soils, rock chip mapping, etc. So yeah, we have used it, but just depending on the area through the Coromandel there that we've been focused on. One thing I didn't talk about, and it was just through time, I did have a slide there for some of the exploration tools, and I think at Waihi, one of the things is why Waihi's there is that very pronounced adularia alteration with the quartz on just a part of the Martha system meant that it outcropped as Martha Hill, as a prominent hill of veining and alteration, and over on Union Hill as well. And for whatever reason, it outcropped. As for most of the deposit, it's undercover with those post-mineral andesites and etc. Dacite, sorry. So it may not have been discovered if we didn't have the more prominent hill sitting there, just as an aside.
Thanks, Craig. Couple of questions that possibly tie into each other. One from Doug Young, the other from David Moore. Is the WKP system open pitable, and have you found any environmental restrictions at WKP?
WKP is probably open pitable, but we have made a firm decision not to open pit anything in the Coromandel. For those of you more familiar, there's various regulations in the Coromandel. Some of the land through the Coromandel sits on Department of Conservation ground, which has various categories of how that ground is managed. So we're very careful in operating at WKP because we are operating in a Department of Conservation area, and I think just in general, all of the areas we're exploring in the Coromandel, we're approaching them as underground operations. As I said earlier, early days people looked at them as open pit, but certainly here at WKP, the grades are 12, 13 grams as a resource. By the time you put mine design, etc., over that, it'll be less, but nice high grade and very, very big width. Some of these combined widths are going 50 meters at, say, 7 grams. So they can certainly be operated well as underground and very little surface impact.
Excellent, thank you, Craig. There's another question there. I'll jump in while anyone else has a chance to get other questions in. You showed a couple of those deeper intercepts and some of the photos of the rock textures at the bottom of Martha with a lot of base metal mineralisation coming in. Does the gold grade drop off rapidly when you start getting the base metals, or are any of those still economic?
Yeah, good question, Peter. The grade of gold does drop off. You still see low-grade gold in these samples, at least where we've done the step-out drilling and defined the chutes in the areas that we've been working at Correnso. these base metals can be up to well over 10% combined base metals, and they can have half a gram or more gold within them. But yeah, nothing economic from a gold exploration perspective. Okay. So the shoots define themselves and fall off, and we haven't drilled deep enough really to understand what happens to the base metals at significant depth.
Fair enough. I don't think you want to be doing a bulk underground carbonate base metal system. Last question, unless someone else jumps in, is also from John Menzies. What happened to the Karahangi mineralisation? I was quite impressed by the veining and alteration system there. That was some time ago. Is there any exploration being undertaken further north in the Thames Peninsula as it's well mineralised?
Okay, John, thanks for the question. Obviously, you're very familiar with the area. So, Correnso, obviously a pretty spectacular set of veins there, very high grade. I think, I don't have the exact numbers on me, but I think the average production grade or head grade when it was in production back in the day was somewhere around 20 grams, or it may have even been as high as an ounce. Not a lot of ounces, I think probably 800,000 ounces, or maybe I'm getting that mixed up with Golden Cross. May actually have been more than that. But there is a company that holds the tenements there. I'm not familiar with how much exploration they're doing, but I'm sure if you Google Correnso, their name will pop up, and you'll be able to follow what they've been doing. As far as the rest of the Coromandel goes, OceanaGold has a good portfolio of projects in the Coromandel, covering what we think is the more interesting or the most interesting prospects. We have tended to shy away from the Thames side or the western side of the peninsula. When you look at age and magmatism and distribution of deposit styles, for those not familiar, there tends to be more of arc-related mineralisation off the western side there, from Thames further north. Things that look more like porphyries and porphyry-associated lower sulphidation mineralisation that was associated again with that subduction. You move across onto the eastern side of the peninsula, and it's dominated by, as I showed in the early figure, back arc, rift, bimodal volcanism, and really low sulphidation, quartz, adularia, gold silver veins. So we're doing a lot of exploration through the Coromandel, focused obviously on WKP because it's without doubt going to be a much larger deposit, and it forms a prominent part of our Waihi district PEA that we came out with, a study, and our production plans going forward over the next 10 plus years.
Excellent, thanks very much, Craig. We seem to have run out of questions, which is actually perfect timing because it's just on 6 p.m. I'd like to thank yourself on behalf of the AIG and the ALS and all the attendees. Thanks very much for your time, Craig. Okay, thank you, and thanks for everyone that joined and had the time to listen to the talk. Excellent, thanks, Craig. And to anyone else who's still listening, we'll be back again in a couple of days' time with the next edition of the RPG Forum. Thanks, everyone, and good night.